This week we will learn a new method of variation of parameters to solve second order nonlinear differential equations. Okay, let's start method of variation of parameters. So we want to find the general solution of second order nonlinear differential equation, and it is non-homogeneous also. So we have y double prime plus pxy prime plus qxy is equal to r of x. So we have a non-homogeneous equation. What is the general solution? We know that the general solution is y complementary plus y particular, where complementary solution is the solution of the corresponding homogeneous part. So when this is equal to 0, the solution is called a complementary solution, and particular solution is a solution which contains no arbitrary constants. Okay, I summarize the methods in 3 steps. So step 1, step 2, and step 3. In step 1, we find the complementary solution C1y1 plus C2y2. So we solve this homogeneous solution of the homogeneous part. So this is equal to 0. And then what is step 2? Then, so it says that you see the method says variation of parameters. So we will make this constant C1 and C2. So we will assume that they are functions of x. So ux and vx. So particular solution is of this form, u times y1 plus v times y2 of this form, and for simplicity we will assume this condition, so just to make the computations easier. So because finding one particular solution, so it is a particular solution, finding one solution which satisfies the differential equation is enough, so we can assume such thing. And then we substitute y particular in the given equation, and we find u and v, the function u and v. Okay, let me solve some examples so we will understand this method. So the question is, find the general solution of y double prime minus 2y prime plus y is equal to e to the power x over x by using the method of variations of parameters. Okay, so in step 1, so we are finding the complementary solution. So y complementary solution of the corresponding homogeneous part, homogeneous equation. So what is it? It is y double prime minus 2y prime plus y is equal to 0, and we know how to find it by using its characteristic equation. So what is the characteristic equation? With characteristic equation, so what is it? It is lambda square minus 2 lambda plus 1 is equal to 0. Okay, let's find the roots of the characteristic equation. This is actually lambda minus 1 square. Okay, so this is lambda minus 1 square. So we have repeated roots equal to 1. So we have repeated roots, and in this case we know how to write the complementary solution, right? So c1 e to the power x plus, if we have a repeated root, then we multiply by x, c2 times x e to the power x, and in step 2 then we will assume these constants c1 and c2 are a function of u and v. Assume y particular is of this form, e to the power ex of this form, and we always and we assume u prime y1 plus v prime y2 is equal to 0. So we always assume this So u prime e to the power x, v prime x e to the power x is equal to 0 in this case. So we will always assume to make this computations easier. And in step 3, oh sorry, I think in step 3 we assume this, but it's okay. Okay, now okay, this is step 3. And now we will substitute yp yp prime, the derivatives in the given equation. So what was our equation? It was y double prime minus 2y prime plus, so we will substitute it. Okay, let's write yp is equal to e to the power x over x, and we will find u and v. So to find u and v, okay, let's find it. So what is so we assume it is of this form. Now I will take the derivatives. What is yp prime? So we need to use product rules. So u prime e to the power x, u, the derivative of e to the power x is itself. So here we have a product of 3 functions. So u, v, w. Then in this case u prime v w plus u v prime w plus u v w prime. So we find the derivative in this case in this way. So v prime x e to the power x, v, the derivative of x is 1, so ex, vx, and the derivative of e to the power x is itself. Okay, now we will take the second derivative. Oh my god. Okay, but we know that, so this is why we assume this. So we know that this total is equal to 0. So we assume that from here we assume that it is 0. Okay, we simplify. That is why we simplify. U e to the power x plus v e to the power x, vx e to the power x. Great. Okay, let's find y double prime. U prime e to the power x, u e to the power x, v prime e to the power x, v e to the power x. Now we, again, product rule, so we will use this rule. V prime x e to the power x, v, the derivative of x is 1 e to the power x, vx times the derivative of e to the power x is x. So here we also have this assumption, so we can use this rule. So these will cancel, and now we will, okay, let me write it, yp double prime. So you have u plus 2v e to the power x plus v prime e to the power x, vx e to the power x. So we need to be careful because you see the calculations are sometimes complicated. Now substitute, let's substitute in the equation. So now yp double prime minus 2yp plus yp is equal to e to the power x over x. Okay, I will copy these things. Oops. So this was yp double prime and then we have minus 2 y prime minus 2 y prime plus yp. So what was yp? U e to the power x so this is equal to e to the power x over x. Okay, now substitute. Okay, now substitute. Now simplify. Okay, we substituted already. Now simplify. And we will get, okay, let me write what we are getting. We will get v prime e to the power x. Sorry, u prime v to the power x plus v prime e to the power x plus x e to the power x is equal to ex over x. And we know, and we assume u prime y1 plus v prime y2 is equal to 0. So u prime e to the power x, v prime x e to the power x is 0. So we have two equations, two unknowns, u prime e to the power x, v prime x e to the power x is equal to 0. So we can find u and v using these two equations, right? So if we multiply with minus this and add them together, so we multiply with minus 1 the second equation and we add to the first one, so we will find v prime e to the power x is equal to, you see these will also cancel, minus v times x minus, so minus v times x e to the power x will cancel with this term v prime x e to the power x, so they will cancel, and when we add we are left with e to the power x over x. Then and we simplify more, so we will find v prime is equal to, we will cancel e to the power x also. Now we can take the integral to find v. So this is ln x plus c, and now we choose c to be equal to 0 because we just wanted to find one function. So choose c to be 0, so v is equal to ln x, and now using the second equation, so okay, using this one, so we know that u prime e to the power x, v prime x e to the power x is equal to 0, and we know v prime is 1 over x, right? So we find it here even. So we will find u prime, so v prime 1 over x times x e to the power x is equal to 0. So we will find u prime e to the power x is equal to minus e to the power x. So u prime is equal to minus 1. Then what is u? Then u is equal to minus x plus c. Again, choose c to be 0 because we just want a simplest function. Then what is y particular? It is u times e to the power x plus v times x e to the power x. So we find u minus x e to the power x. What is v? ln x. Okay, I will write x here. And x e to the power x. Then what is the general solution? So we know that general solution is y complementary plus y particular. What was y complementary? So we find y complementary here, right? Okay, I will copy it. and then this is our, okay, I will write, copy it here and then delete. So this was y complementary plus y particular, so it is x minus x e to the power x, x ln x e to the power x. So this is our general solution.